Okay, so we're looking at Wednesday's work today. We're continuing on with our indices. These ones you're going to find quite challenging. The most important stuff is that you're comfortable with the previous day's work. So if this is very, very difficult, go back and do yesterday's Monday's questions again. But they're supposed to be challenging. These are kind of stretching now the limits of your knowledge of indices. So the first one up, solve 3 to the power of x equals 81. So as we can see, the x we're looking for is up here in the powers. So how you do that's a simple rule. If the x is in the powers, make your base numbers the same. How do I do that? Well, 3 to the power of x is equal to 81. But could I make 81 3 to the power of something? Now you can do that in your calculator. You can do 3 to the power of 1, 3 to the power of 3, and on and on and on until you get 81. And that's what you'll do at the start until you kind of see the pattern here and get the hang of doing them, and you'll see the same numbers occurring over and over again. But when you do that, you'll find out that 81 can just be written as 3 to the power of 4. So it's 3 to the power of 4. So if 3 to the power of x is equal to 3 to the power of 4, then obviously x is equal to 4. Right, looking at a second and third example here. Find the value of x for which 4x to the power of minus 1 is equal to 32. Well, let's have a look at that. So again, we're looking for something that's up in the powers. So could I make 32, could I write that as 4 to the power of something? Well, let's put it into our calculators. Well, 4 squared is 16, so that's not going to work. So let's try 4 cubed. 4 cubed is equal to 64. No, I can't get 32. So is there another number I could use? Well, I could write 4. I know that 4 is 2 squared, right? So could I write 32 as 2 to the power of something? So let's try that. Into our calculator, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. Aha! So I could write both of them as 2 in powers of 2. So 4 is 2 squared, but that's still to the power of x minus 1. And 32 is 2 to the power of 5. So let's have a look at this. What happens in this situation? Do you remember the last day? You got brackets and powers. Well, you can multiply. That's 2 to the power of 2x minus 2 equals 2 to the power of 5. Now, if they're equal to each other, if 2 to the power of 2x minus 2 equals 2 to the power of 5, then obviously 2x minus 2 must be the same as 5. So 2x minus 2 must be equal to the 5. The powers must be equal because our base numbers are the same. So 2x is equal to 5 plus 2. 2x is equal to 7. X is equal to 7 over 2. Having a look at the next example. We'll do it in blue. So solve this equation. 4 to the power of x plus 2 equals 8 to the power of 1 minus x. So I've got x's on both sides this time. So I've got 4 to the power of, oopsie daisy, apologies. I've got 4 to the power of, 4 to the power of x plus 2 equals 8 to the power of 1 minus x. So anytime I've got x's up here in the powers, up here, I have to make my base numbers. My base numbers are my big numbers in green here. My big numbers the same. I have to make the 4 and the 8 the same. So I have to see 4 times 1, 4 to the power of 1 is 4, 4 to the power of 2 is 16. So 4 won't work. So what number could I express them both as? Well, I could express 4 as just 2 squared. 2 squared is 4. And I could express 8 as 2 cubed. So I can express them as the same base number. So instead of 4, I could write 2 squared, and that's still to the power of x plus 2. And instead of 8, I could write that as 2 to the power of 3. And that's still to the power of 1 minus x. Now, when I've got brackets in this situation, I multiply. So it's 2 to the power of 2x plus 4. and I multiply again. 3 times 1 is 3, 3 times minus x, so 2 to the power of 3 minus 3x. So my base numbers are the same, so my indices must be the same as well. So 2x plus 4 must be equal to 3 minus 3x. X is to one side, so 2x plus 3x is equal to 3 minus 4. So 5x is equal to minus 1. X is equal to minus 1 over 5.